Hey guys, happy Monday, back at it. Hopefully you guys had a good weekend. We got one more week of the quarter left. And so basically what I wanted to tell you guys was, like check your grades in Power School. What I'm doing for the Algebra I class is that you can retake one test, right? Every quarter. So if there is a test that you would like to retake this quarter, what I'd like you to do is let me know that by tomorrow. And on Wednesday, I will send you that test. And then you will send it back to me by the end of school on Wednesday. Completed, obviously. So it won't be the same test. It'll be like another version, which I'll make. Which is some stuff that I'll have to do this week, but I think Wednesday will work for that. So just let me know. An email is fine. If you don't want to retake one, you're happy with your grade now, that's completely fine too. The only thing that's really going to change your grade this week, it would be homework. Obviously, just do your homework and get that turned in, and you'll be fine. So yeah, that's what I wanted to tell you guys for end of the quarter stuff. We're going to talk about the exponential function today. We're going to start with the parent function, if you will, and we'll just do f of x equals 2 to the x. So notice that we have an exponent now that is an x. That is going to be the key feature of the exponential function, okay? And this number, the 2, could change. I guess if you wanted to be picky about it, you could say this is the parent function of exponential growth, but we'll talk a little bit more about that. So today we're just going to kind of get our bearings on what this thing is going to look like and talk a little bit about some new things that maybe you are not going to be familiar with, right? So best place to start if we're talking about a new function is to make a table of values. And we always want to know what's going on both sides of 0. So I'm going to go from -2 to 3, because that's how far I drew. And we're just going to plug these in, right? So be careful here when you're plugging them in. So 2 to the -2nd power. We know negative exponents makes it a fraction. And 2 times 2 is 4. So that's going to give me 1/4, right? Use those exponent rules we talked about last week, kind of figuring that out for me. If you put this in your calculator, just be careful. With negatives always are tricky, right? If I go to the -1st, that's going to make it a fraction. That would just be 1/2. If I go to the 0 power, we talked about this last week too. Anything to the 0 power is always going to equal 1. So that is going to be 0, 1. 2 to the 1st power is just 2. 2 to the 2nd power, 2 times 2 is 4. And 2 times 2 times 2 is going to get you 8. So this is a table of values on what this parent function is going to look like. But let's look at the graph, because I think that's going to tell us some information too, right? So all right, so if I plot my points here, notice -2, 1/4. 1/4, it's going to be less than half, somewhere here. Obviously, you're going to have to estimate a little bit, right? Because I'm not going to be really picky on like, ooh, that looks more like a third than a fourth. I don't care. -1, 1/2. Again, just kind of in between there. 0, 1. 0, 1. 1, 2, so over at 1, we go up to 2. 2, 4. 2, 1, 2, 4. And 3, 8 is all the way up. Cool. All right, so what you can see here, let me connect so you can see it a little bit better. Maybe I'll use a different color. get all fancy with you here. We'll go straight old school Chicago Bulls on you. Okay, so what you see here is we have this curve, right? What you're going to find is that the exponential functions are not going to be linear functions. They're going to have this curve to them. Because when we're increasing an exponent, all right, it's going to increase a lot more rapidly. In fact, it's like a percentage growth, right? If we look at how this changes, if this was linear, we would add the same number every single time. Here, we're multiplying the same number, right? Multiply by 2, multiply by 2, multiply by 2, multiply by 2. I can keep going. But you can see how that's not a linear change that we're used to, all the ones you've seen so far. This is non-linear, which is interesting. Two sides of this thing are kind of interesting, right? What's going on over here? What is going to happen if we continue, right? Is there some number that I could plug in here where the y value, the output, is going to be 0? Is this going to touch 0? The answer is no. There's no number that you could plug in for x here that's going to get you a 0 as an output. And so this is really interesting. What you have here is called an asymptote. I know, funny word. Asymptote. Kind of has like a silent P in it, asymptote. An asymptote is a spot on a graph where there will never be a line that crosses that. There's something mathematically that is stopping any points from reaching that area. And in this case, it's an x as an exponent. There's no way to get to 0 if x is my exponent here in this situation. So there's a horizontal asymptote is what we would say. You could also have a vertical asymptote. We don't in this case, but a vertical asymptote would be like the same thing. Something that would cause it to not move any farther. Now you might think this looks like it's curving up so fast that maybe there would be one, but it's going to go forever, right? If I plugged in 100 for x, there's going to be some spot way up there that's going to have a number here. So there is a horizontal asymptote, which means this thing is never going to get to 0. What's going to happen is we're going to, just because we're dividing by 2, if we go this way, it's just going to keep getting closer and closer and closer and closer. So even though it looks like, hey, this thing is getting real close to 0, it's probably going to cross, you guys have to know that since there's a horizontal asymptote here, we will never ever reach 0. Okay? That's a big thing. I think, what else do I want to talk about? Well, yeah. I'm going to talk about, I think I'm going to kind of split this into 2 days. And I think we'll talk about like domain and range and things like that tomorrow. But I mentioned that this was exponential growth. So there's also something called exponential decay. And to look at that, we're looking at this number right here, like this base, if you want to think of it that way. If it's greater than 1, we have growth. If it's greater than 0, but we'll say x. We can't use x. We'll say b for the base, okay? If it's greater than 0, but less than 1, we have something called exponential decay. And exponential decay is going to work the same way, only it's kind of like we're flipping our graph. It's going to go down, okay? It's kind of like how medicine works in your body. Basically, it's going to take, some away at a time, then some more away, then some more away. right? That way medicine works for a longer period of time. So let's say we had the parent function for exponential decay, I would say, is y equals 1, or f of x equals 1/2 to the x power. So if this number is a fraction, if it's less than 1 but greater than 0, we're going to see our numbers decreasing. So to kind of show you what that'll look like, right? So now if I put -2 in here, -2, what that's going to do is hang on, we got to do that. There we go. So what -2, if I have that for my exponent, think of power to a power, it would go to both. And then it's going to flip the 2 to the negative. Here, I should probably write those down. Like this, over this. And what that's going to do is flip this thing, right? So that's going to be 2 squared over 1 squared, which is just 4. And so see here, we're starting at a higher number. And what's going to happen is if I do 1/2 to the -1, that's actually going to be 2. If I do 1/2 to the 0, that's going to be 1. 1/2 to the 1 is 1/2. 1/2 squared is 1/4. And this would be 1/8. So you see how what's going on here is the exact opposite now. If we think of our table of values, instead of multiplying by 2 every time, I'm multiplying by 1/2 every time as I go down. Everything's getting 1/2 as big. So real quick here, just to show you what decay is going to look like, we're still going to have that horizontal asymptote. All right. So -2, 1, 2, 3, 4. -1, 0, 1. And then we see it starts to get smaller. So we're starting up here. And we're going that way. Now this line technically will never get horizontal. Also, I know that's kind of weird just to think about, but it's just going to keep creeping towards 0. But this is kind of decay, right? We start high and it's going to slowly decrease. Or decrease quickly and then slowly decrease, right? So it's not a linear change. It's, again, nonlinear. All right, so that was a good intro. We'll pick it up tomorrow, learn some more.